Alright, so before we understand how motors work, we have to understand how electricity works. All electricity is the movement of electrons from point A to point B. This is because everything in the world of science wants equilibrium, in the sense that everything is even. So, in science, electricity goes from negative to positive, in the sense that there's a high quantity of electrons in one area to a low quantity. While in engineering, it goes from positive to negative in the sense that it is high voltage to low voltage. So, same concept of high quantity of electrons to a low quantity. And for this video we're going to be using the concept of engineering, of electricity. Now we have to understand how a current works. So a current is just the flow of electrons through a wire, usually a copper wire, and it's measured in volts, which is the difference in the charge of electrons between 2 points, and you have to take into account the resistance which the wire makes. The next step for understanding how motors work are magnets. So a magnet is simply a north and south pole in which opposites attract. So north is attracted to south and south is attracted to north. And every magnet has a south and north pole. Okay, now within a magnet and an electric wire, electricity can be drawn. Now you're probably saying, what? How can magnets have any correlation with electricity? Well, it's actually the same thing, just a different way to interpret it. In the same way, time and space are the same side of a different coin. Now, electricity can be drawn by moving either a wire through a magnetic field or moving a magnet past an electric wire. And electricity will be drawn through the wire, which will conduct electricity. And this is the basis for pretty much all motors, the movement of a wire and magnets. Okay, now that we understand magnets and electricity, we can move on to motors. So in a motor, there are two types of currents. There's alternating current and direct current. In alternating current, the electricity will flow from positive to negative and vice versa, in the sense that if you have a battery, it will be moving from positive to negative and then negative to positive, back and forth 60 times every single second. Well, this is the standard in the United States, as it oscillates at 60 hertz, which is the measurement for the amount of times that the electricity oscillates. And it's at 120 volts, which is how much electricity is going through the wire. Now, the difference between alternating current and direct current is the fact that in direct current, electricity is constantly flowing in the same direction. Now, this is a quick visual representation of what alternating current looks like in contrast to direct current. As you can see, direct current has the same troughs, while alternating current has alternating. Okay, now that we've gone over electricity and magnetism, we can understand how a motor functions. So here in this representation, we'll have the blue part of the wire and the pink side of the wire. So per se, the blue part of the wire is naturally inclined to want to turn towards the south side and turn 180 degrees, and the pink side will be wanting to turn towards the north side, right? But if we alter the current as they arrive to their point, then it'll switch the polarity, as we can see here. The polarity has been switched and the wire will continue to rotate. As you see here, the voltmeter is facing to the right and here it is to the left. Thus, this is alternating current, which allows us to continually rotate. And that's basically how a motor works. You have your north and south pole, which are causing a magnetic field. You pass an alternating current through the wire, which will allow it to rotate and oscillate and continually rotate. And you have a bearing, which will allow the metal rod to spin, and this is how motors work.